Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with a test.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
Good morning everyone. I welcome you all to India's largest e-learning platform, Unacademy and the GATE Conqueror channel. Guys, please confirm the video and audio. Confirm the video and audio, dear. I welcome you all to the BARC marathon session number 2. In the first of this particular session, I'll be dealing with wave propagation for the first 1.5 hours, and the second 1.5 hours, I'll take up communications. Yes. Good morning, Pratap. All clear. Both are fine. Rishabh, very good. So let us start the session. Let me introduce myself. I'm GC Reddy. I have 12 plus years of teaching experience in teaching, guiding and mentoring GATE and ESE aspirants. I've mentored around 1 lakh of students for these competitive exams. Subjects I handle is EMTL, communications and advanced communications for ESE. You can use the code GCR10 to get 10% off on Unacademy Plus subscription. For all those serious aspirants, I recommend you to go for a Plus subscription so that the results are good and bright. Before we start, let me explain about Unacademy special classes which are featured on the Unacademy app. By special classes, you get the interactive live sessions where you get maximum interaction and maximum knowledge. You have polls. Polls are treated to be the best way of learning. So we also have the option for polls for the learners. And of course, by once you on the notification, you never miss out the notification. And after each session, you also get the lecture notes. You can access at any time from anywhere. This is about the Plus subscription I was talking about. If you consider a Plus subscription, you get the face time of legendary faculties in the form of live classes, crash courses, weekly test, doubt solving. It will be explained in both Hindi and English. And also you have rank improvement batch to improve your rank. That means we try to address different set of audience for different requirements in the Plus subscription. And Iconic subscription is a very unique one. It covers all the Plus subscription features. Along with that, you also have a personal coach for your guidance. You have the material to download, and you have personalized test analysis. Writing tests is a different level, and doing the analysis and understanding what our strong subjects and weak subjects is a very important thing. That is provided in Iconic subscription. Consider for an Iconic subscription for your better placement and better preparation. These are the subscription values of Plus for 12 months, 18 months and 24 months. You can get it for 32,450, 41,300 and 47,200. If you use the code GCR10, you get 10% discount on the same. It's for Iconic subscription. As you know, we have the additional added value things for Iconic subscription. You get 12 month, 18 month and 24 month subscription for the value of 50,250, 64,500 and 74,000. Also, you have a no cost EMI facility for both Plus and Iconic subscription, so that you can avail that particular EMI. And also you can use the code GCR10 to get 10% discount. These are the values. These are the amount that you need to pay after the 10% discount for both Plus and Iconic subscription. And these are the batches that are going on now in Unacademy. Crack GATE 2022 for GATE 2022 aspirants. Arohan GATE 2023 this is for GATE 2023 aspirants. Both of these batches, all legendary faculties are teaching here, including the God of Machines. K.N. Rao sir will also address, is a part of team for this particular batches. And this for ECE, you can see all the important names, all the famous people are here for that particular batch also. Yes. Sorry, I was not looking for the comments. Yes. Natul, good morning. Thank you, Adya. Thank you. These are the batches for the additional subjects. As you know, ESE has some additional subjects. To cover the additional subjects, we are also having different batch called Target ESE Prelims 2022. Just try to concentrate on this, so that along with this GATE, you will also get prepared for your additional subjects. ESE subjects will also be covered, so that your parallel preparation will be done by using this Target batch. This for ECE and this for electrical, the Target batch. Now, in our particular session, we start off with EMTL wave propagation, the very interesting wave propagation. I start with basic concepts and I try to build on that. As usual, you know my style. I start with basic concepts and try to build on that, so that the one who had just joined this particular session and do not have some prerequisites will also be covered here. And for those who already have prerequisites, it will be a refreshment for them or a revision for them. And this is the best offer I can find. With 6 months of Plus subscription, you get plus 3 months subscription absolutely free. 9 months of rigorous study must be enough to clear any exam, including GATE. So this is the best subscription I can find. 6 months subscription if you take, then you get 3 months subscription free, so that you can do your preparation within 6 months itself. So that's the ideal time, and we also have time now. We also have this much of time in order to evaluate our particular preparation strategies for GATE and ESE. And this is the bugs bounty. If you find any mistake, technical mistakes in our educators classes, you can also raise the same to reward, and you'll be rewarded for the same. This you can follow me on the Unacademy app using this link. Kindly make a note of this link so that you can follow me on the Unacademy app. So we are into EMFT session, and in this particular session we'll discuss about wave propagation. So I start up with the basic concept of what is a wave, and we try to build our particular knowledge on that. Vishnu, good morning. Arpit saying good morning, dear. Yes, share the session, dear everyone. Share, like and subscribe. Share the session to as many as possible so that this valuable content is reaching to many. Please do the sharing, because at the start of the session will go long for 3 hours. The first 1.5 hours I'll be concentrating on wave propagation, and the next 1.5 hours we'll concentrating on communications. Here goes the first question. From wave propagation. Keep joining, dear. Keep joining, keep sharing. Try out the first question, dear. Yes, everyone. Try out the answer. Just let me know what's the answer. Confirm the video and audio, dear. Is it all good? Yeah, please respond in the chat box. Try to find this answer. Electric field is given, dielectric material, properties are given, specifications are given. You need to find 4 different things here. Yes, Kirti. Others also please try. Good morning Sai Bhavan. Because sure, option D, very confident. So let me explain some basic concepts, shall I? Shall we start to explain some basic concepts, some theory? Shall we? According to definition, can you tell me what is wave? What is an EM wave? Atul, Pavan, please share the class, dear. Saloni. What is an EM wave? An EM wave is called a TEM wave, transverse electromagnetic wave. It is called a transverse electromagnetic wave as electric field and magnetic field are perpendicular to each other and they are perpendicular to direction of propagation of wave. That's why it's called transverse. Transverse means perpendicular. What are perpendicular? Electric field and magnetic field are perpendicular to each other and they are perpendicular to direction of propagation of wave. Such waves are called TEM waves. For example, if you consider a TEM wave, when we consider a TEM wave, propagating along Z direction, if you consider a TEM wave propagating along Z direction with electric field along X direction, with electric field along X direction and magnetic field along Y direction, the wave is propagating along Z direction and electric field is along X direction and magnetic field is along Y direction. That means you have EX and you have HY. Wave is propagating in Z direction. Now you see, how is the wave propagating? Wave is propagating in Z direction. Himanshu, sir, if I want to practically understand and work on antennas, which book can I start with? For practical approach, Cross is a very good book. Okay, dear. For a practical approach, Cross is a good book, dear. Yes. Yes. Keep sharing, dear. Keep sharing. Now, we'll concentrate back on this. This is a TEM wave. Am I right? The TEM wave is propagating in Z direction with electric field along X direction and magnetic field along Y direction. How is electric field and magnetic field? Electric field and magnetic field are perpendicular to each other and they are perpendicular to direction of propagation of wave. Such waves are called TEM waves. Such waves are called TEM waves. Now you may say, if the wave is propagating in Z direction, what is the other combination that is possible? The other combination that is possible is, you have magnetic field along X direction and electric field along Y direction. You may have magnetic field along X direction and electric field along Y direction. That's the second combination possible. Here also, electric field and magnetic field are perpendicular to each other and they're perpendicular to direction of propagation of wave. Now you tell me, is there any third combination possible? Please share the session, dear. Is there any third combination possible? I'll write out the combinations. The first combination is EX and HY. When the wave is propagating along Z direction, the combination is EX and HY. What are the components which are 0? EY is 0. EZ is 0. HX is 0. HZ is 0. I was asking some question for you. Is there any third combination possible? No, Arpit, what I am asking is, if the wave is propagating along Z direction, is there any third combination of components possible? Two combinations that I explained are EX and HY, HX and EY. Is there any third combination for the wave propagating in Z direction? Is that clear, Arpit? This is the first combination. The second combination is electric field is in Y direction, magnetic field is in X direction. Okay. So which components are 0? EX is 0. EZ is 0. HY is 0. HZ is 0. These are the other combinations that you have. I'm right. This is for the second combination, EY, HX. Is there any third combination possible for the wave propagating? For the wave propagating along Z direction. Is the thickness of the pen good, dear? How is the thickness of the pen? Is it good? Visible? Yes, I'm just waiting for the answer, dear. My question is there any Kirti? Yes, my question is there any third combination possible? There is no other combination possible. Now, most of you know, if I am not wrong, most of you know that the definition of a TEM wave is electric field and magnetic field are perpendicular to each other and they are perpendicular to direction of propagation of wave. Am I right? But I'll give you one more definition for TEM wave. A TEM wave propagating in Z direction, the components of electric field and magnetic field in that particular direction is always 0. That's the second combination. Sorry, that's the second definition. The second definition is, what is the first definition? The first definition is, if you have an EM wave propagating in any given direction, electric field and magnetic field in that particular direction is 0. Other is electric field and magnetic field are perpendicular to each other and they are perpendicular to direction of propagation of wave. These two are definitions of a TEM wave. Is that clear? So that's about TEM wave and their two definitions. The first definition tells that electric field and magnetic field are perpendicular to each other and they are perpendicular to direction of propagation of wave. Perpendicular to direction of propagation of wave. The second definition states that the component of electric field and magnetic field in the direction of propagation is always 0. If the wave is propagating along x direction, Ex, Hx are always 0. The wave is propagating in y direction, Ey, Hy are always 0. The wave is propagating in z direction, Ez, Hz are always 0. Okay? That's about TEM wave. Now I'll ask you one more simple question. I need an answer from you. What is a wave? Can anyone define? What is a wave? See, without these basic concepts, you will not understand wave propagation. So I want to explain what is a wave. What is a wave? Share the session, dear. Yes. The question is, what is a wave? If I draw a wave, it looks like this. This is a wave. What is the distance covered by the wave? What is the distance covered by the wave? 0. Here the distance covered is 0. What is the distance covered here? Lambda by 2. What is the distance covered here? Lambda. What is the distance covered here? Lambda by 4. What is the distance covered here? 3 lambda by 4. Distance covered by a wave to complete one cycle. The distance covered by the wave to complete one cycle is called wavelength. It's called wavelength. Am I right? So what is the wavelength? Wavelength is given by lambda, or wavelength is given in terms of lambdas. The distance covered by the wave to complete one cycle is called wavelength. What is the time taken to cover one cycle? What is the time taken to cover one complete cycle? The time taken to complete one cycle is time period T. The time taken to complete half cycle, T by 2. Time taken to cover 1/4 of the cycle, T by 4. 3/4 of the cycle, 3T by 4. 3T by 4. This is time period. What is the phase shift that is undergoing? Phase shift. I'll ask you one question. What is the definition of a wave? I'm waiting for that. What is the definition of a wave? Yes. What is the definition of a wave? What is the phase shift undergone? 0 pi 2 pi pi by 2 3 pi by 2 0 pi by 2 pi 3 pi by 2 2 pi. Now how to define a wave? Wave is something which is having oscillation. Very good, Saloni. Kirti, 2 pi r, not 2 pi r, 2 pi. It's 2 pi, Kirti. A wave is one which changes its phase with respect to time and space. Note down. Note this point, very, very important point. A wave is one which changes its phase. A wave is one which changes its phase with respect to time and space. Can anyone tell me what is the term that gives you the change of phase with respect to time? What is the term that gives you the change in phase with respect to time? Okay, can anyone tell me what is this omega? What is omega? What do you call omega? Angular frequency. Can anyone tell me what do you understand by the term angular frequency? You might have using this for years together now, angular frequency. What is angular frequency, omega? What it is telling you? The time displacement. How, Atul? How omega will give you time displacement? Let us see. If you go for time period T is 2 pi by omega. Time period for oscillation. From this, omega is 2 pi by t. Omega is 2 pi by t. Okay. Omega is 2 pi by t. What it is telling you? 2 pi phase shift. 2 pi is the total amount of phase shift undergone for time period t. Therefore, omega is telling you amount of phase shift per time period t. Therefore, 2 pi is this 2 pi radian per time period second. That is the reason why omega, angular frequency, as unit radian per second. It tells you the amount of phase shift that is undergone per time period t. Unit radian per second. Is it clear? What is time and space? That is what I am explaining. I'll explain one by one, Saloni. I'll explain time and space concept now. Okay. One second. Omega is angular frequency. It gives you the change of phase with respect to time. Omega is 2 pi by t radian per second. Am I right? 2 pi by t, which is radian per second. Now if you do omega into t, for example, you are taking t is equal to 0. Yet t is equal to 0. What is the value of omega t? What is the value of omega t at t is equal to 0? At t is equal to 0, omega t is 0. Am I right? Just give me 2 minutes of break. Small adjustment in the technical thing. I will just come back in 2 minutes. Okay? Not 2 minutes. Just within 1 minute. Okay?
It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
where you put your knowledge to test.
and battle it out with a test.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner
Am I audible, dear? Yes. So I was talking about omega t, am I right? Omega t, a t is 0, omega t is equal to 0. Now, a t is equal to t by 4. What is omega t? Omega t is omega 2 pi by t into t by 4. How many t's? Pi by 2. A t is t by 4. Its value is pi by 2. A t is 0, it is 0. A t is t by 4, the value is pi by 2. Am I right? Yes. Now if you see, a t is 0, it is 0. A t is t by 4, it is pi by 2. A t is 0, at time t is 0, phase shift is 0, a t is t by 4, phase shift is pi by 2. Now if you do similarly, a t is equal to t by 2, omega t 2 pi by t into t by 2. The phase shift is pi. The phase shift is pi. A t is t by 2, the phase shift is pi. A t is t by 2, the phase shift is pi. Got it? So what does it mean? Omega t is giving you the change of phase with respect to time. Got this concept? I challenge you, you cannot find this concept anywhere in any book. You cannot find it in this precise manner. We've done a lot of analysis to make you understand exactly what is wave. You might have studied waves these many days, but from now, the way you study, the way you, the perception of yours towards waves will be completely different now. Omega t will give you the change of phase with respect to time. And what is a wave? A wave is one which changes its phase with respect to time and space. So every wave must include omega t term, because omega t will tell you the change of phase with respect to time. Now, but a wave is one which changes its phase with respect to time and space. So who is telling you the change of phase with respect to space? For that, we introduce one more term called beta. What is beta? Phase shift constant. It will tell you the change of phase shift. It will tell you the change of phase shift. Beta is given as 2 pi by lambda. Beta is given as 2 pi by lambda. the change of phase shift with respect to lambda space, unit 2 pi radians per distance in meter, radian per meter. That's why unit of beta is radian per meter. It gives you the change of phase with respect to space, to radian per meter, 2 pi by lambda, just like 2 pi by omega. Now if you take, for example, now the wave is propagating in which direction? Yes, now the wave is propagating in which direction? Everyone share the session here. I'm going to tell some very important concepts in waves. You might have not gone through before such important concepts I'm going to tell. Please share the session, okay? So what is beta now? Now where is the wave propagating? The wave is propagating along z direction. So you take beta into z. Beta into z will give you the change of phase with respect to space. With respect to space. For example, if the wave is propagating in x direction, then beta x will give you the change of phase with respect to space. If the wave is propagating in y direction, beta y will give you the change of phase with respect to y direction. Beta z, because I assume that the wave is propagating along z direction, beta into z. Now at z is 0. At z is 0, how much is beta z? 0. At z is lambda by 4. How much is beta z? Beta is 2 pi by lambda into lambda by 4. Phase shift is pi by 2. Phase shift is pi by 2. Now you see, at z is 0. At z is 0, phase shift is 0. At z is lambda by 4, phase shift is pi by 2. Similarly, at z is lambda by 2, phase shift is pi. At z is lambda by 2, phase shift is pi. Z is 0, phase shift 0, lambda by 4, phase shift pi by 2, lambda by 2, phase shift is pi. See the wave, Z is lambda by 2, phase shift is pi. So what is beta Z now? Beta Z is giving you the change of phase with respect to space. And every wave is one. A wave is one which changes its phase with respect to time and space. Therefore, the change in phase with respect to space is given by beta Z if the wave is propagating along Z direction, beta Y if the wave is propagating along Y direction, beta X if the wave is propagating along X direction. So every wave must include these two terms, omega t and beta Z. Clear? Every wave must include these two terms. Omega t will give you the change of phase with respect to time, and beta z will give you, or beta y will give you, or beta x will give you the change of phase with respect to space. So every wave must include these two terms. Is that clear? Now if you see the question, what is given in the question, now you get more clarity, because now the question is E is equal to 30 cos of 10 power 8t minus 1 by root 2x into ay. Into ay. What is the general form? General form is E is equal to E naught cos of omega t minus beta x into ay. If you compare, how much is omega? 10 power 8 radian per second. How much is beta? 1 by root 2 radian per meter. The electric field term is having both omega t and beta x. Now you tell me, is your understanding towards the wave is improved or not? It is very clear that this fellow has an amplitude of 30, omega t minus beta x. It is having omega t beta x. It must be wave. Where omega t is giving you the change of phase with respect to time, beta x is giving you the change of phase with respect to space. Yes, because correct. If it is traveling in xy plane, they would have omega t minus beta x minus beta y, both components. Correct. Correct. Very good. Now you tell me, now is the perception towards this equation is changing or not? If you see this equation, now you feel more comfortable or not? Now, we'll go for the question. Question is only a media through which I explain. That's it. Question is not that important at all. Now let us see. Direction of propagation. Please tell me the answer. What is the direction of propagation? What is the direction of propagation? Just tell me what is the direction of propagation. 30 cos of omega t minus beta x is there. What is the direction of propagation? Positive x, Sudhir, positive x, very good. Why positive x? Atul, Sudhir, others, why positive x? Who is telling you that this is positive x? In this equation, who is telling you? This wave is talking to you now. Am I right? This wave is talking to you. It is telling you something. Which part of the wave is telling you that I am going in positive x? Arpit. Which part is telling you that it is positive x? If I am not wrong, omega t minus beta x. Omega t minus beta x. By seeing this, you are saying that the wave is propagating in positive x direction. Am I correct? But how omega t minus beta x will tell you that the wave is propagating in positive x direction? Omega t, the change of phase with respect to time. Beta x, the change of phase with respect to space. The difference between them in any wave, the difference or the sum between them is always constant. Do you agree? बहुत कम स्ट्रेंथ है यार. The strength is very low. Come on, share it. Okay. Omega t is change of phase with respect to time. Beta x is change of phase with respect to space. The difference between them is always constant. Difference or the sum is always constant. omega t minus beta x is some constant k. If you do differentiation, omega into dt minus beta into dx is 0. Now what do you get? Omega into dt is beta into dx. Dx by dt is omega by beta. Dx by dt is omega by beta. What is x? X is a direction in which it is propagating. Rate of change of displacement. What is rate of change of displacement? Velocity. Okay. Why it is constant? Who is asking that? Because omega t is giving you the change of phase. What it is giving you? Change of phase with respect to time. Beta x is giving you the change of phase only again, with respect to space. Both are telling you same thing with respect to two different concepts. The difference between them is always constant. No, it is like you are running here and I am running here with the same velocity. The difference between you is always constant, no? Okay. Got it? Omega t minus beta x, why it is constant? It is clear? Now, dx by dt is velocity. But how can you justify that v is omega by beta? Dx by dt, rate of change of displacement, is velocity. That's okay. But how can you say omega by beta is velocity? If you take a wave, velocity is distance by time. What is the distance measured here? In lambda. How is time measured here? Capital T. So velocity is lambda by t. If you multiply and divide by 2 pi, time period t is 2 pi by omega. Omega is 2 pi by t. This is omega. 2 pi by t is omega. 2 pi by t is omega. Lambda by 2 pi is 1 by beta. From this, omega is velocity v is equal to omega by beta. Clear? Difference is that, see here, beta x or beta y is telling you the change of phase with respect to space. Omega t is telling you the change of phase with respect to time. At any given point, the space that is consumed here and the omega t that is traveled is constant. This minus this, if you do, it is always constant. It is like two people running with some distance at equal velocity. The difference between them is always constant, because both are talking about the same wave. Both are talking about the same wave. Both are talking about the same phase. Both are telling you the same phase. Clear? So velocity is omega by beta. Omega t minus beta x. Velocity is omega by beta. It is indicating that the wave is traveling in positive x direction. Therefore, omega t minus beta x implies positive x. Similarly, if you take omega t plus beta x, which is constant, omega into dt plus beta into dx is 0. Omega dt is minus beta dx. Omega by beta is minus dx by dt, implying that the wave is propagating in negative x direction. Is it clear? Now that's the reason why omega t minus beta x means positive x direction. Omega t plus beta x means negative x direction. Is it clear? Now, in the given equation, you have omega t minus beta x. Omega t minus beta x means the wave is propagating in positive x direction. Is it clear? Next, what is the velocity of propagation? What is velocity of propagation? We got formula now. V is omega by beta. Calculate and tell me. Calculate velocity and tell me. Because sure, I'll give you one example. Wait. This is one staircase. This one staircase. I'll keep it more slant, okay? You're in a two-story building. This is one staircase. This is one more staircase. This is how they build the ramp. At any point, the difference is constant. One is talking about beta, other is talking about omega. One is talking about beta, other is talking about omega. You are moving forward. Similarly, the wave move forward. The wave will also move forward. The change in phase. Because see, both are talking about the same concept called phase. One is telling you the change of phase with respect to space, other is telling you the change of phase with respect to time. But both are talking about the same thing. Okay. Omega by beta 10 power 8 by 1 by root 2. Root 2 into 10 power 8 meter per second. But if you see carefully, unit here given is kilometer per second. So convert into kilometer. Root 2 into 10 power 5 kilometer per second. Root 2 is 1.414. 141400 kilometer per second. 141400 kilometer per second. By this you can confirm that option C is the answer. because no other option is having plus x and 141400. You should be careful. You should not write root 2 into 10 power 8. At an instant you will feel it is root 2 into 10 power 8 because initial answer you get it is root 2 into 10 power 8. If you neglect, if you overlook your unit, then it will be a very big problem for you. Am I right? When you are talking about electric field here, when we are talking about electric field, we talk like what is electric field equation? Because what is electric field equation? Dou square E by dou x square is equal to mu naught epsilon naught into dou square E by dou t square. We are taking this space term separately and time term separately. It is changing with respect to both space and time. Both are talking about the same thing, but here it is telling you the change of phase with respect to space. Here it is changing change of phase with respect to time. Both are changing. If it is constant, both will be zero, no? I hope you got it. Next, intrinsic impedance. Intrinsic impedance is how much? Now, can anyone tell me what is intrinsic impedance? What is intrinsic impedance? What is intrinsic impedance? I hope because I'm able to clear your doubt. Omega t minus beta x is talking about the relativity. If you are going, for example, Bikash, if you are going on a bike with uniform velocity, how much is your acceleration? How much is your acceleration? If you are moving with uniform velocity, how much is your acceleration? Anyone can answer. Meanwhile, you tell me what is intrinsic impedance? Acceleration is 0. Does it mean that you are not moving? If acceleration is 0, does it mean at any case that you are not moving at all? No, I am right. Same concept, okay? Now, intrinsic impedance. Next is intrinsic impedance. Can anyone tell me what is intrinsic impedance? What is intrinsic impedance? Anyone please define what is intrinsic impedance? For example, we are considered a wave propagating in z direction with electric field along x direction and magnetic field along y direction, electric field along x direction, magnetic field along y direction. Now, tell me what is intrinsic impedance for this wave? Do anyone have an idea of what is intrinsic impedance? Please let me know. Magnitude of electric field and magnetic field present in free space is called as intrinsic impedance. Good answer. Other than that, Anik Mitra, very good. Other than that, now you just imagine the wave is propagating. The wave is propagating. You have electric field, you have magnetic field. The wave is propagating. Just imagine the wave is propagating. Imagine. Did you imagine? The wave is propagating. Now just stop the wave. Stop the wave. Okay? And at any point, you just stop the wave, and at any point, you take the value of electric field and the magnetic field. The ratio of magnitude of electric field E naught to the ratio of magnitude of magnetic field H naught will be equal to intrinsic impedance of the wave. If the wave is propagating in free space, it is eta naught. This you know, am I right? At least some people know this. At least some people know up to this that E naught by H naught is eta naught. Am I right? Beyond this, there is some other concept. What is that? At any point, this eta naught is under root of mu naught by epsilon naught. What is mu naught by epsilon naught? Mu naught. What is mu naught? Permittivity of free space. Sorry, mu naught. The permeability of free space. It tells you the behavior of the media to allow magnetic field. Epsilon naught. It tells you the behavior of the media to allow electric field. What is mu naught value? 4 pi into 10 power minus 7 Henry per meter. Epsilon naught value 8.854 into 10 power minus 12 Farad per meter, or 10 power minus 9 by 36 pi Farad per meter. Solve it. You solve this, what do you get? This pi will move up, pi into pi, pi square will come out as pi. 36 will move up, 36 into 4, 144, under root 144 is 12. 10 power minus 9 will move up. 10 power 9 into 10 power minus 7. That 10 square, that will move out 120 pi. It's 120 pi. What is 120 pi? 377 ohm. What does it mean? 120 pi or 377 ohm. What does it mean? What do you understand by this 377 ohm? That means when a wave is propagating in free space, this is free space which is having mu naught and epsilon naught. This free space, what is the free space impedance? the free space impedance is eta naught, which is under root of mu naught by epsilon naught, which is 120 pi ohm, which is 377 ohm. What is the wave impedance? Eta naught, which is magnitude of E by magnitude of H. How much it is? It is also 120 pi. It is also 377 ohm. What does it mean is, this wave is having impedance of 377, or only when the wave will have impedance of 377, or when the ratio of electric field to magnetic field is 377, this free space will allow impedance matching. There is a impedance matching at each and every point. You think that wave is just moving. No. Wave is moving means its impedance is 377 in free space. Only when E by H ratio is 377, then only the wave will allow. Got this? The wave will move only when its impedance is matching to the impedance of the free space. Most of the people will understand only one concept, not two. You should understand both. Here the impedance is 377. Here also it is 377. It is impedance matching concept. At each and every point impedance matching is happening. Then only the wave is getting allowed. Is that clear? Is that clear, dear? Very good. So what is happening here? At each and every point, there is a impedance matching happening. The impedance of the wave is 377 ohm. Impedance of free space is 377 ohm. And each and every point, impedance matching is happening. Had you seen Avatar movie? Avatar. Had you seen Avatar movie? Yes. You'll have dragons, am I right? In Avatar, you'll have dragons. You remember dragons? Very dangerous ones. Initially, when we try to take control of the dragon, it will not allow. Same is the case. Only when the impedance matches, there will be, in Avatar he will show you, there is some synchronization between that dragon and the human being. Then only it will allow. Same is this. If this wave wants to enter into free space, it must maintain E by H is equal to 377. Then only it will allow. Okay. Now, the wave wants to enter into a dielectric. The wave wants to enter into a dielectric. Here it is in free space. It is in free space. Free space is having mu naught. Free space is having mu naught and epsilon naught. Free space is having impedance of 120 pi. Free space is having impedance of 377 ohm. Wave is also having impedance of 377 ohm. Wave is also having impedance of 377 ohm. Free space is also having impedance of 377 ohm. Matching is happening, so it is traveling. Now it wants to enter into this dielectric. What happens? Now it wants to enter into this dielectric. What happens? Will it allow? Will it allow? That is what? Now the wave is having impedance of 377 ohm. This dielectric will have its own mu value and epsilon value. It has its own impedance. What is the impedance of this dielectric? Impedance of the dielectric medium eta is equal to under root of mu by epsilon. Example, this is under root of mu naught epsilon naught, under root of mu naught by epsilon naught into under root of mu r by epsilon r. Under root of mu naught by epsilon naught is 120 pi. Let mu r of the medium is 2. Epsilon r of the dielectric is 2. Let this be 8. And this is 2. Under root of 2 by 8. This is 120 pi into under root of 1 by 4. 120 pi by 2. 60 pi. 60 pi ohm. Means what? Impedance must match. The impedance here is 60 pi. This fellow is offering only 60 pi ohm. Okay. It is offering only 60 pi ohm. But this fellow is having 120 pi ohm. That means what? The electric field and magnetic field must vary. The electric field and magnetic field must vary. And now the wave must exhibit 60 pi. The ratio of electric field to the ratio of magnetic field must be 60 pi. Then only the wave is allowed. This wave impedance must be 60 pi. Because eta here is 60 pi. Changes will take place. Because of that, losses also will happen if you have sigma. Very good, Adil. Is that clear? Yes. Intrinsic impedance is, same example, epsilon r is 8, mu r is 2 is taken. So just now I had calculated intrinsic impedance eta 120 pi into under root of mu r by epsilon r. It will be 60 pi. Got it now? What is magnitude of H? You know, the ratio of E to H is eta. How much eta you got? We know the ratio of E to ratio of H is eta, which is 60 pi. Just now I explained. How much is E you got? 30 by magnitude of H is 60 pi. What is magnitude of H? 30 by 60 pi. 1 by 2 pi. Unit ampere per meter. 1 by 2 pi ampere per meter. 1 by 2 pi ampere per meter. Is it clear? Share the session, dear everyone. Quick and fast, share the session. Okay. There's some problem in the question. Fine, we'll do this. Do this question and tell me the answer. In good conducting medium, omega is 10 power 8 pi. Sigma is 10 power 5 Simon per meter. Mu r is equal to 2. Find alpha, beta and delta. In a good conducting medium, omega is given as 10 power 8 radian per second. Sigma is given 10 power 5 Simon per meter. Mu r is 2. Is asking us to find alpha, beta and gamma, alpha, beta and delta. What is alpha for good conductor? In a good conductor, alpha is under root of omega mu sigma by 2. Under root of omega 10 power 8 pi mu naught into mu r. Mu naught 4 pi into 10 power minus 7. Mu r 2 sigma 10 power 5 by 2. 2 and 2 get cancelled. 2 and 2 get cancelled. What do you get here? Pi into pi, pi square. Pi will come out. Under root 4, 2 will come out. Under root 10 power 8 into 10 power minus 7, 10 into 10 power 5, 10 power 6. Under root 10 power 6, 10 power 3 will come out. What is the answer? 2000 pi Nepper per meter. 2000 pi Nepper per meter. Am I right? Find beta. For good conductor, beta is also under root of omega mu sigma by 2. You'll get same answer. 2000 pi radian per meter. and delta is 1 by alpha. If we get 1 by 2000 pi. 1 by 2000 pi. Atul, had you calculated using formula? Had you calculated this using formula, dear? If you are calculating by using formula, you are actually wasting a lot of time. The small logic I'll tell you shortcut. For good conductor, alpha is equal to beta. And if you see the options, in none of the options, first two options are same, only except C. So without any calculation, in 2 seconds, if you apply the logic, you can directly write the answer as C. Got it? That's a shortcut here. Identify the true statements. Velocity with which the wave propagates in free space. Velocity with which the wave propagates in free space is more than that of a dielectric medium with finite epsilon r and mu r. Ignore this. Intrinsic impedance of free space is less than the intrinsic impedance of a dielectric medium with epsilon r greater than 1 and mu r is equal to 1. Tell me the answer. After this question, I'm going to take the break. After this question, I'll give you a break of 5 minutes. Now you tell me what is that I need to teach after this. Shall I continue with EMT or shall I start communication? For the next 1.5 hours, what shall we do? Shall we continue communication? Or shall we continue? Or shall we start communication? Shall we start communication or continue EMFT? Option A is the answer you are saying. Let us see. Velocity with which the wave propagates in free space is velocity of light 3 into 10 power 8 meter per second. Is more than that of a dielectric medium with finite epsilon r and mu r. Velocity with which the wave propagates in any given medium depends on epsilon r and mu r value. Formula is C by under root of mu r epsilon r. Finite value of mu r and epsilon r means mu r is greater than 1, epsilon r also is greater than 1. Naturally, the velocity with which the wave propagates will be less. The velocity with which the wave propagates in a medium will be less than the velocity with which the wave propagates in free space. Now you read the statement. Velocity with which the wave propagates in free space is more than that of the dielectric medium with finite epsilon r and mu r value. Correct. The velocity with which the wave is propagating in free space C is greater than the velocity with which the wave propagates in a given medium V. So this statement is true. See the next statement. After the break, I'm asking, shall I continue EMFT or shall I start communication? Next, intrinsic impedance of free space is less than the intrinsic impedance of dielectric. Intrinsic impedance of free space is less than the intrinsic impedance of dielectric. What is intrinsic impedance of free space? Intrinsic impedance of free space eta naught is under root of mu naught by epsilon naught, which is 120 pi ohm, which is less than intrinsic impedance of a medium, which is under root of mu by epsilon, which is under root of mu naught by epsilon naught into mu r by epsilon r. 120 pi into under root of mu r is 1, epsilon r is greater than 1. This value is greater than 1, so value of eta will be less than 120 pi. What is given? Intrinsic impedance of free space is less than intrinsic impedance of the dielectric. No, intrinsic impedance of free space is more than that of the dielectric. So this statement is false. True and false. Option A is the answer. If I am starting communication, I will continue with analog communications. If I am going for EMFT, I will continue this. Shall we continue EMFT? Okay. Okay. Please share the session in this gap. At least in this gap, you share the session among all your contacts. We'll come back in 5 minutes, not more than 5 minutes. In 5 minutes, we'll come back and continue some more questions of EMFT. In the first hour, we had concentrated more on the theory. That theory is helping you in solving these questions very easily. So that will be continued. Because you have good theory now, the questions will become easy. We'll do more and more questions in the second 1.5 hours. Okay? So let me take a 5-minute break. Meanwhile, you share among all your friends. Thank you.
It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
where you put your knowledge to test.
and battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now. It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
where you put your knowledge to test.
and battle it out with a test.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now. It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test.
and battle it out with a test.
To bring out the best in you,
Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now. It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
where you put your knowledge to test.
and battle it out with a test.
to bring out the best in you.
Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now. It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test.
and battle it out with a test.
to bring out the best in you.
Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now. It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
where you put your knowledge to test.
and battle it out with a test.
To bring out the best in you,
Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
Hello all dear. Please confirm the video and audio. Let's continue the session. Continue the questions of EMFT. One more question for you. Yes, Anandi Meena, just it was a layover break for 2 minutes. We are back now. Identify the true statements. In a good conductor, alpha is equal to beta. In a good conductor, beta is 1 by delta. Penetration depth is less at higher frequencies. Penetration depth is more at higher frequencies. Which of these options are true and what is the answer? Good morning, Anandi Meena. Vikas Shah. Thank you, dear. As we know, in good conductor, alpha is equal to beta. This statement is true. In good conductor, beta is 1 by delta. This is also true. Penetration depth is less at high frequencies. Penetration depth is less at high frequencies. Penetration depth is less at high frequencies. You know, alpha is equal to beta, and you know, penetration depth delta is equal to 1 by alpha. In good conductor, alpha is beta, therefore delta is equal to 1 by beta, or beta is equal to 1 by delta. Therefore, second statement is also true. Now, we know for good conductor, alpha is under root of omega mu sigma by 2. Delta is 1 by alpha, it is under root of 2 by omega mu sigma. If you expand this, under root of 2 by omega, 2 pi of mu sigma, 1 by under root of pi of mu sigma, 1 by under root of pi of mu sigma. Therefore, delta is proportional to 1 by under root f. If frequency increases, the penetration depth decreases. That's why high frequency waves will penetrate less into the conductor while they travel. If you take a high frequency waves will penetrate less into the conductor while they travel. Whereas low frequency waves will penetrate more into the conductor and travel. You can see the difference. So what's the option now? Penetration depth is less at higher frequencies. Is more at higher frequencies is wrong. Penetration depth is less. High frequency waves penetrate less into the conductor while they travel. 1, 2, 3 are true. For option A must be your answer. Atul, 3 is also correct. Three is also correct. Am I right? So 1, 2, 3. Option A is the answer. Clear? For a TEM wave, propagating in x direction in free space, the component of electric field along x direction is 0. The component of magnetic field along x direction is 0. Electric field and magnetic field are perpendicular to each other and they are perpendicular to direction of propagation. Ratio of magnitude of electric field to magnitude of electric field to magnetic field is always 120 pi ohm. Which of these statements are true? Already we have discussed a lot in the first half of the class. We have discussed a lot about this. Which of these options are true? You know, for a TEM wave, transverse electromagnetic wave, the component of electric field, a TEM wave is propagating along x direction. The component of electric field along x direction is 0. True, am I right? As I told you, when a wave propagates in x direction, Ex is 0 and Hx is 0. This is true. The component of magnetic field along x direction is 0. This is also true. Electric field and magnetic field are perpendicular to the direction of propagation. Not only electric field and magnetic field are perpendicular to each other, they are perpendicular to direction of propagation by definition. This is also true. And the ratio of magnitude of electric field to magnetic field in free space is 120 pi because the wave is propagating in free space. Therefore 120 pi. This is also true. All the options are true. A, B, C, D. 1, 2, 3, 4 I mean to say. Option D is the answer. Good one. Next. This is alpha, okay? If alpha C, beta C and VC are attenuation constant, phase shift constant and velocity of wave in good conductor, and if beta D, alpha D, beta D and VD are attenuation constant, phase shift constant and velocity in good dielectric, then replace this by alpha C here. This is alpha D. Alpha C, beta D. Beta C, beta D. What's the relation? Good conductor, good dielectric, okay? You know, for good conductor, we know for good conductor, alpha attenuation constant is under root of omega mu sigma by 2. In a good conductor, sigma is far greater than omega epsilon. Therefore, good conductor will experience more attenuation. Generally, we think if it's a good conductor, attenuation will be less. No, that's not the case. In good conductor, sigma is more. Good conductor will attenuate more. For example, if you are standing here and there is iron wall here, and the wave is transmitted from an antenna in this way. Second case, wave is transmitted and there is a wooden wall. You will experience more attenuation. While it is passing through iron, then it is passing through wood. It experiences more attenuation here. Is it clear? So it experiences more attenuation here. It experiences less attenuation here. Alpha C is greater than alpha D. Attenuation in conductor C is more. So what's the conclusion? Waves attenuate more in conductors than dielectrics. Generally, we feel it will attenuate less in conductors, but not the case. Okay? Yes. Beta. How about beta? You know, for good conductor, alpha is equal to beta. Beta is also under root of omega mu sigma by 2. Same case, it undergoes more phase shift in good conductors than good dielectrics. And we know velocity is omega by beta under root of 2 by omega mu sigma. Sorry. Do omega by beta under root of 2 omega by mu sigma. In good conductors, conductivity is more. So what happens to velocity? It will increase or decrease? Velocity will increase or decrease? In good conductors, conductivity is more, no? So what happens to velocity? In good conductors, wave travel with less velocity when compared to good dielectrics. So velocity with which the wave is propagating in good conductor is less than that of dielectric. Alpha C is greater than alpha D. Beta C is greater than beta D. VC is less than VD. These will be your options. Alpha C is greater than alpha D. Beta C is greater than beta D. VC is less than VD. Therefore, option D is the answer. Got it? Yes, correct. Answer this. Pointing vector at any point gives dash. Pointing vector through given area gives dash. Pointing vector at any point, pointing vector, average pointing vector, P average is 1 by 2 real part of E cross H conjugate. That is 1 by 2 E cross H conjugate mod E, mod H. E and H are perpendicular to each other, sin 90. So P average is 1 by 2 mod E mod H. Electric field is volt per meter unit. Magnetic field is ampere per meter. Volt into ampere, that's power. Watt per meter square. So pointing vector, this is average pointing vector. So pointing vector will always give you what? Pointing vector will always give you power density. When you pass this power density through a given area, it gets multiplied with meter square. Watt per meter square into meter square, it gives you watts power. Got it? So what is the answer? Pointing vector at any point gives you what? Power density. Whereas pointing vector through given area gives you power. Power density and power. Option B is the answer. Got it? I hope the concept is clear. Yes, Arpit. Which of these represents average pointing vector? Which of these represents average pointing vector? P average is 1 by 2 real part of E cross H conjugate, 1 by 2 mod E mod H, and we know mod E by mod H is eta. Substituting from this H is E by eta, 1 by 2 E square by eta. In terms of H, E is eta H, 1 by 2 eta H square. Average power. One by 2 mod E mod H, 1 by 2 E square by eta, 1 by 2 real part of E cross H conjugate. One by 2 eta H square. Which of these options are correct? 1 by 2 eta H square correct, 1 by 2 E square by eta correct, 1 by 2 real part of E cross H conjugate is correct. Therefore, option B is the answer. Clear? Loss tangent value. Loss tangent value for good conductor, good dielectric, perfect conductor and perfect dielectric is loss tangent is also called as dissipation factor. Loss tangent is also called as dissipation factor. Loss tangent or dissipation factor is given by tan of phi, where phi is 2 times of theta n, where theta n is angle of intrinsic impedance. Is given as sigma by omega epsilon. Is given as sigma by omega epsilon. If you want to understand about loss tangent, for a good conductor, sigma is far greater than omega epsilon. Sigma by omega epsilon is far greater than 1. Sigma by omega epsilon at least greater than 100, then it's a good conductor. For a good dielectric, sigma is far less than omega epsilon. For good dielectric, sigma is far less than omega epsilon. Sigma by omega epsilon is far less than 1. Sigma by omega epsilon is less than 1 by 100. Sigma by omega epsilon is less than 1 by 100. For a perfect conductor, sigma is infinity. Loss tangent is also infinity. And for a perfect dielectric, sigma is 0. Loss tangent is also 0. For a good conductor, loss tangent is greater than 100. So, most probable answer is either B or D. For a good dielectric, it is less than 1 by 100. 1 by 100 means 1 by 110 or 1 by 110. Perfect conductor, it's infinity. Perfect dielectric, 0. Option D must be your answer. Therefore, option D must be your answer. Loss tangent will give you, if you know the loss tangent value, the loss tangent will give you for it at a particular given frequency, the particular conductor will work or particular material will work as a conductor or a dielectric. Because at different frequencies, the behavior of the dielectrics will change. They behave like good conductors, good dielectrics and all. So that this loss tangent will tell you at a given particular frequency, how is that particular material behaving? Is it behaving like a good conductor or a good dielectric or a quasi-conductor or a quasi-dielectric? If you have the ratio between these two, sigma by omega epsilon is greater than 100, it's a good conductor. Sigma by omega epsilon is less than 1 by 100, it's good dielectric. If you have sigma by omega epsilon between these two, that it is sigma by omega epsilon is less than 100 and greater than 1 by 100, then you call it as quasi-conductor. Quasi-conductor or quasi-dielectric. So at a given frequency, How is that material behaving? Is it behaving like a good conductor, good dielectric, quasi-conductor or quasi-dielectric is decided by what? Loss tangent. Because, is that clear? Okay. Next question. An EM wave with amplitude of electric field is 10 volt. First case in perfect dielectric, epsilon r is 8 and mu r is 2. Second case perfect dielectric with epsilon r is 16 and mu r is 1. Find the average power, average pointing vector in watt per meter square. Okay. Find it. Average pointing vector one by 2 real part of E cross H conjugate, or it is one by 2 E square by eta one by 2 eta H square one by 2 mod E mod H 1 by 2 E square by eta 1 by 2 eta H square or 1 by 2 mod E mod H. E value is given 1 by 2 E square by eta. For that I need to find eta value. In the first case, eta value is 120 pi into under root of mu r by epsilon r. 120 pi into under root of 2 by 8. 120 pi by 2. 60 pi ohm. 60 pi ohm. Okay. It is 60 pi ohm. Substitute and tell me the answer. One by 2 E square 100 by 60 pi. 5 by 6 pi. For the first case. Second case, eta is 120 pi into under root of 1 by 16. 120 pi by 4, that is 30 pi. This is 30 pi. Substituting 1 by 2, 100 by 30 pi. 100 by 60 pi. 5 by 3 pi. 5 by 3 pi. One is 5 by 6 pi. The other is 5 by 3 pi. One is 5 by 6 pi. other is 5 by 3 pi. Therefore, option C is the answer. Clear? Yes, correct. Bikash correct. Prashant Rawat correct. Yes. This one. Electric field Ex is given as 30 into e power minus j 100x ay plus 9 into e power minus j 100 x into az. What is the kind of polarization for this? What is the kind of polarization for this? In second option, E is given as sine of omega t minus beta z ax plus sine of omega t minus beta z plus pi by 2 ay. Polarization is given by, what's the answer here? Question number 12, what is the answer? If you speak about polarization, polarization is of three types. One, linear polarization. Two, circular polarization. Three, elliptical polarization. What is linear polarization? You say that the wave is linearly polarized. First you tell me what is polarization. What is polarization actually? Orientation of electric field gives you polarization. No, not Arpit. Orientation of electric field decides polarization. In this, there are three cases. Linear polarization. You say when the wave is said to be linearly polarized, when you have components of electric field with equal amplitude or unequal amplitude. Amplitude can be equal or unequal, but same phase. They must have same phase. Then you call it as linear polarization. When do you call it as circular polarization? When your components are of equal amplitude and out of phase by 90, then you call it as circular polarization. Elliptical polarization, when you have unequal amplitude and the components are out of phase by 90, then you call it as elliptical polarization. If none of these conditions are satisfied, then we call it as unpolarized wave. Unpolarized wave means the above three conditions are not satisfied. Sure, Atul, sure, I'll do it. Okay. Everyone share in our Telegram groups. Please share the class along with some caption, some customized message that what we are teaching here, so that the other students will also understand. Am I right, Adil? So basing on this, now tell me the polarization. How is the amplitude here? Amplitude is unequal. How is the phase? Phase is equal or same phase. When you have same phase and unequal amplitude, what is the polarization here? When you have same phase and unequal amplitude, what is the polarization? As a phase is same or equal, it must be linear polarization. Therefore, answer must be A or D. Next is to understand the next option, whether it is left or right circularly polarized. Is it left? LEP means left elliptically polarized. REP means right elliptically polarized. LCP means left circularly polarized. RCP means right circularly polarized. How to understand this? Now see the amplitude. Amplitude is 1. You have equal amplitude. Phase omega t minus beta z plus 0. This plus 90. Out of phase by 90. Equal amplitude and out of phase by 90. Equal amplitude and out of phase by 90 means what? Equal amplitude out of phase by 90 means circular polarization. Now the question is it left circularly polarized or right circularly polarized? How can you tell whether it is a left circularly polarized or right circularly polarized? Anyone? Can anyone tell me whether it is a left circularly polarized or right circularly polarized? Is it left circularly polarized or right circularly polarized? Y component is leading X component. So what? Left or right? How do you tell it is left or right? I'll tell you shortcut, wait. Now you see here. This theta is equal to 0 degrees. This is theta is equal to 90 degrees. This is theta is equal to minus 90 degrees. Left or right you should tell, okay? You should tell whether it is left or right. Now, note down the first phase shift. Note down the first phase shift, 0. Note down the second component phase shift, plus 90. First to second. How it is moving? Clockwise. Clockwise. Clockwise means left. Anti-clockwise means right. Now you tell me, is it left circularly polarized or right circularly polarized? Is it left or right? This theta is 0 degrees. Theta is 90. Theta is minus 90. 0, 90, minus 90. If the movement, in this particular case, I got movement as clockwise. Clockwise means left. Anti-clockwise means right. So, yes, Arpit, correct. It must be 0 to 90 means clockwise. Clockwise means left circularly polarized. Linear and left circularly polarized. So what's the answer? Linear and left circularly polarized. So what's the answer? Option A is the answer. Got it? Is it clear? But there is a small problem here. Because now I am teaching, you'll understand clockwise means left, anti-clockwise means right. Sometimes what happens is in examination, the moment when you are attempting this question, you'll get the doubt. Clockwise is left or right? Today it's okay because just now you had understood the concept. Clockwise means left, anti-clockwise means right. Up to 1 week it's okay. After 1 week when you are trying to solve the question, you'll solve everything, but at the last you'll get this doubt. Clockwise is left or right? Am I right? Had you experienced such a thing while you're writing exam? Can you share your experience? Had any one of you experienced such thing? Like Karn will forget his weapons at the important time. We'll also get confusion between left and right, clockwise, anti-clock. So how to overcome this? How to overcome this problem? I'll tell you a trick so that you'll remember for a long time, or you'll remember this concept permanently. Now if you see the wave, what are the components of electric field? E is equal to is EX AX EY AY. E is EX AX plus EY AY. Components are EX EY. Am I right? And how is the wave propagating? Omega t minus beta z. The wave is propagating in the positive z direction with components of electric field along x and y. Wave is propagating along z direction with components of electric field along x and y. X axis, y axis, EX, EY. Wave is propagating in z direction. Means how is the wave propagating? Wave is propagating along z direction. Means how is the wave propagating? Wave is propagating perpendicular to this board like this, with electric field having components along x and y. With electric field having components along x and y. Am I right? So the wave is propagating along z direction with components of electric field along x and y. So wave is propagating towards you. Am I right? Please respond. I'll tell you a trick now. Remember, wave is propagating out of this board. In the direction of propagation of the wave, keep your thumb. See here. See the orientation. It is matching which hand? The orientation is matching left hand. Therefore, it is left circularly polarized or left elliptically polarized. If it does not match, it is right elliptically polarized or right circularly polarized. Got it? Or shall I explain again? लेफ्ट हैंड को मैच हो रहा है तो लेफ्ट सर्कुलरली पोलराइज्ड, राइट हैंड को मैच हो रहा है तो राइट सर्कुलरली पोलराइज्ड, लेफ्ट हैंड को मैच हो रहा है तो लेफ्ट एलिप्टिकली पोलराइज्ड, राइट हैंड को मैच हो रहा है तो राइट एलिप्टिकली पोलराइज्ड. जिस हाथ को मैच हो रहा है वो ओरिएंटेशन, उस हाथ का पोलराइजेशन है. हाथ तो अलाउड है ना, हैंड्स आर अलाउड. इन ऑल एग्जाम्स हैंड्स आर अलाउड. हैंड्स विल बी विथ यू. You can check then and there. You need not remember by heart. Left is clockwise, right is anti-clock. Am I right? That's the concept. Tell me this now. Is cos of omega t minus beta x plus 45 degrees beta z, okay? Omega t minus beta z plus 45 into x plus 40 cos of omega t minus beta z minus 45 degrees of ay. Tell me the polarization. Second one is ax plus jy e power j (2 pi into 10 power 70 minus 0.2 z. 13th B. Arpit, think again. First one. Amplitudes are equal. Amplitudes are equal. Phase plus 45 to minus 45. Total phase shift 90 degrees. Equal amplitude out of phase by 90, circular polarization. But there are two choices now. Not this, not this. It can be B or C. Left or right, you tell me. How do you tell left or right? Shortcut method. Theta is 0. Theta is 90. Theta is minus 90. First one, 45 degrees. Second, minus 45 degrees. Orientation. Orientation from this point to this point. Trapped है ना? आंसर क्या है फिर? What's the answer? See the orientation. Which hand? Orientation, right hand. Right circularly polarized. Right circularly polarized. Now you tell me how this fellow is left elliptically polarized. How to solve this? AX 1 into AX plus J 1 into AY. This is 1 into AX into 1 लिख सकते हैं ना? 1 को कैसे लिखेंगे आप? How do you write 1? E power J0 plus 1 into AY. J को कैसे लिखेंगे? प्लस J E power J pi by 2. What is E power J pi by 2? E power J pi by 2 cos pi by 2 plus J sin pi by 2. Cos 90 plus J sin 90. 0 plus J1. J can be written as E power J pi by 2. Am I right? Okay. Yes. So equal amplitude क्या ऑप्शन गलत है क्या? 4 हाँ 4 है सॉरी 4 है ना 4 है हाँ सही है गॉट इट करेक्ट yes Bikash very good I overlooked हाँ 4 is also there yes unequal amplitude out of phase by 90 इस बार माई ट्रैप हो गया unequal amplitude out of phase by 90 unequal amplitude out of phase by 90 0 to 90 orientation 0 to 90 orientation 0 to 90 left elliptically polarized option C is the answer got it next one incident angle for which there is no reflection is called as brevest triangle incident angle for which there is no transmission is called as brevest triangle brevest triangle is given by theta I is equal to tan inverse of under root of epsilon 2 by epsilon 1 for a medium with epsilon 1 is 1 and epsilon 2 is 3 brevest triangle is 30 degrees find out SDR find out incident angle for which there is no reflection is called as brevest triangle true by definition no doubt in this incident angle for which there is no transmission is called as brevest triangle no what it is called as TIR total internal reflection false brevest triangle formula theta I tan inverse of under root of epsilon 2 by epsilon 1 tan inverse of under root of epsilon 2 by epsilon 1 so this is true for a medium with epsilon 1 is 1 and epsilon 2 is 3 find the brevest angle is 30 degrees verify theta is tan inverse of under root of epsilon 2 by epsilon 1 tan inverse of root 3 60 degrees but what is given here it is given as 30 false so what is the option true false where it is option C is the answer got it is it clear Next question. Next question. Identify the correct statements. Identify the correct statements. The angle of incidence at which the reflection becomes zero if the wave is parallelly polarized is called Brewster angle. By definition, Brewster angle is the angle of incidence for which reflection will become zero, but Brewster angle is only defined for parallelly polarized waves. It is not defined for perpendicularly polarized wave. A parallelly polarized wave is one where electric field is parallel to the plane of incidence, whereas a perpendicularly polarized wave is one where the electric field is perpendicular to the plane of incidence. So by definition, statement 1 is true. Next one. There exists an angle of incidence at which reflection coefficient becomes unity. There exists an angle of incidence for which reflection coefficient becomes unity. This angle is called critical angle. By definition, what is critical angle? Critical angle is the minimum angle of incidence for which total internal reflection is possible. Whatever is the incident wave will reflect back. Incident electric field is equal to reflected electric field. When incident is equal to reflected, reflection coefficient gamma is reflected field by incident field, which is 1. So what is saying? There exists an angle of incidence at which reflection coefficient becomes unity. This angle is called as critical angle. Yes, correct. So both A and B are correct. Option C is the answer. Very good, Arpit. For a medium with epsilon R1 is equal to 6 and epsilon R2 is equal to 3, calculate total internal reflection and Brewster angle. Calculate and tell me the answer. Calculate and tell me the answer, dear. Total internal reflection theta I is equal to sin inverse of under root of epsilon 1 by epsilon 2, provided epsilon 2 is greater than epsilon 1. Theta is sin inverse of under root of epsilon 2 by epsilon 1, provided epsilon 1 is greater than epsilon 2. Whichever is greater will come into denominator because sin value cannot be greater than 1. That's the logic. 15th, okay, is done. 16, try 16. Try 16th question, dear. Try question number 16. Option C, let us see. Epsilon R1 is 6, epsilon R2 is 3. Whatever is greater will come in the denominator. Therefore, using this formula, the sine inverse of under root of 3 by 6, sine inverse of 1 by root 2. This is 45 degrees. TIR, total internal reflection, is 45 degrees. Brewster angle irrespective of the value of epsilon 1 and epsilon 2, it is fixed. Tan inverse of under root of epsilon 2 by epsilon 1. Tan inverse of under root of 3 by 6. Tan inverse of 1 by root 2. If you calculate, you get around 35 degrees. So 45 and 35. Option C is the answer. Is it clear? Very good, very good, very good. Bikash, wonderful. Arpit, wonderful. Arpit, you need to solve for 16, Arpit. Identify which of the following will not satisfy the wave equation. Very simple, okay? We've done a lot of theory on this. If you had gone through my theory, this is very easy to explain. This is sin x, okay? Sin x into cos t. Answer, 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 answer. In the first option, we have omega t and beta z. I told you a wave is one which has both terms, omega t and beta z. Omega t will give you the change of phase with respect to time. Beta z will give you the change of phase with respect to space. You have both. This is wave. Here also we have omega t, beta z. This is also wave. Here it is of the form sin beta x into cos omega t. Beta is 1, omega is 1. It is a form of standing wave. It is a form of standing wave. Okay. So that is also a wave. Which is not wave? We have omega t but not beta z. Direct answer. Option C is the answer. Is that clear? We have omega t but not beta z or beta y. So this has only omega t, change in phase with respect to time, but no change in phase with respect to space. If we don't have beta x or beta y or beta z, therefore you cannot treat this as a wave. Option C is the answer. Clear? We'll come back again at 3 p.m. with one more marathon. Satish sir, KN sir, Hari sir will join us and we'll have a marathon from 3 p.m. to 10 p.m. In that marathon, I'll start EMF. We'll concentrate on static fields and time varying fields. Okay, dear? And tomorrow morning, 10 a.m. to 1 p.m., we'll have separate marathon for this EMF and communications, where we'll deal with wave propagation concepts. Okay? Thank you all. Thank you all. Don't forget to subscribe, share the session, like the session and subscribe. And don't forget to share it. After you watch, you share it among all your friends so that it will reach to larger audience. Thank you all.